Mr. Minnick here, helping my AP Computer Science A exam students learn how to trace previous year solutions to the free response questions with the goal that if they know how to trace previous good answers, they will probably be able to model those answers with loops and if statements in the current year's exam and not be totally intimidated and frustrated and not know where to start. Here goes. In the year 2014, there was a question that involved composition where a class name seating chart has as an instance variable property a two-dimensional array of student objects where the student class was also provided on the test paper. And the job of part A on that exam that year was to implement a other constructor of that seating chart class. So here's the stuff that you would be reading on the day of the exam, and you would see that you have to implement it in part A, and the precondition and the postcondition is right there. It's also worded then on the next page of the exam, and they even give you a nice little example of the things involved, the data, sample data. So on the day of the real exam, you are going to have to write this code from scratch. But let's just start out here by tracing an answer, and you'll see this year that you will probably have an exam question where you have to take data from a one-dimensional array or array list and somehow dump it into, transfer it over to a two-dimensional structure, data structure, probably a 2D array. So here goes. Let's trace this question from last year, at least this solution. Notice there's an alternate solution that we may have time in this video to trace. Oh, I'm sorry, that's the wrong answer. Sorry about that glitch a second ago. Here is the page of answers provided online at collegeboard.org that we are tracing. That matches up with this question over here. Here goes, seating chart. There's an alternate version that we may have time to address, but here's the version that we're going to trace. So the first line of code that this solution includes is an instantiation of seats. So you needed to note that you had to do that. Seats is the instance variable property that is part of the seating chart class, and it's declared here, but it's not instantiated with the keyword new, nor is it given an exact size of number of rows and columns. That kind of task is typically done in a constructor for a class. So it's the job over here in the constructor to do that. Do not write out student square bracket, the data type in front of the word seats here. Don't include all of this information over here. It's just the seats equals and then this instantiation part. Now where does rows and columns come from? It comes from these parameters, which you are supposed to assume somehow over in a client program some number of rows and columns is specified. Well, their example is something that has 3 rows and 4 columns. Do not hardwire your answer with 3 rows here and 4 columns. That's a typical mistake. You'll certainly lose a point on the rubric if you hardwire your code with specific numbers, other than starting things at 0 like this. So and besides, your answer, your implemented code should always make use of every parameter that's given in the header that was provided for you. So rows and columns, COLS, are being used up here. And we both know that in this example data that you want to kind of use as a model here, since they drew the picture, you can kind of think of that as 3 and 4, and not 2 and 3 because of the 0 nature of this. Okay, so that line of code hopefully you understand. And now the next line of code that their solution knew to provide, they needed a variable that that kept track of where they are as they iterate through this one-dimensional array list. They need like a marker, a tracker. So they knew to add a variable. Now they could have named this anything they wanted. They could have named it I, or the word index, or the word position. But they used the name student index. So I'll work with that here as I help you understand their code. Well, when I teach people to trace code, they should always keep track of stuff and variables like this. So I'm going to keep track of student index by making a little column for it. I'm going to keep track of its precise value so I totally understand the magic that's going on here on this complicated answer. It's being initialized to 0. Okay, check. We did that and that. Now we hit this double nested for loop. Okay, hold on tight because this is going to be a lot of code to trace and plow through. So here it goes. Column equals 0. So we have a variable called column. I'll keep track of it here. Don't be confused. Column is singular there without the S. They use calls, well, that's the for. They probably should have used C, but they use calls, so I'll work with it. Or call, they use call, so I'll work with that. Normally, when you see double nested for loops that work in conjunction with a two-dimensional array in my class that I'm teaching, the outer for loop is normally row and the inner loop is column. Because normally when we work with algorithms that involve these things, we go row by row top down, going across each row until we fill it up or add up things or whatever, searching for things, and then we go down. That's traditional. But the trickiness of this AP question this year was that they wanted you to go column by column. See that? Tricky. And if you inverted these two for loops and put the row variable on the outside and the column variable on the inside, you would surely lose a point on the rubric. Just saying. Okay, back to our tracing. So we have a little variable column that starts at 0 here. Check. Column is less than columns. We'll just pretend that columns is 4 for now because we've hardwired this example in our mind. And column is currently 0 and 0 is less than 4, so we do go into the outer loops area, body area, where we have a variable called row. Now I write the word row here, but that's kind of misleading to put it over there. So I'm going to purposely put the variable named row here. You'll see why later. And so that I do that, and I proceed with my tracing. That's equal to the number 0. Check. Row currently is 0 and it is less than 3, which is what the value passed in as a parameter for rows is. We don't row plus plus yet, just like we did not column plus plus yet. You better know how to trace a for loop. You do not plus plus an increment on that first iteration through a loop. No way. Okay, so we get to this if statement for the first time. If student index, which is currently 0, is less than all of this. So what the heck is this? Student list.size. Oh, that's easy. Student list.size is, well, let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Even though over here in this array list, the position, the index position subscript numbers would be 0 through 9, the size of this array list is 10. And I don't say length, because length is what you have with arrays. Size is what you have with array lists. So that's the number 10, and that's going to be the number 10 throughout this whole tracing. So I'm just going to put a 10 in there, because that's not going to change. Moving on. Because 0 is indeed less than 10, we do hit this body statement of the if. Okay, this is pretty tricky. It's an assignment statement that works from right to left. So what is this over here on the right? Well, let's work from inside the parentheses out. Student index is currently 0. When you do a dot get 0, that means you're getting whatever's in the 0 position over here of student list. And I can't, with my marker, I can't write student list here. It's not writable. So just know that this is student list. Now they're calling it roster here. which is fine if that's the parameter, if that's the instance variable name in the class. But here, in the context of this method, student list, it's known as student list, which roughly matches with the actual parameter roster, but don't be confused by this notation. Okay, well, anyway, we're putting Karen3, that whole object, that whole student object, Karen3, where she missed, I think, 3 days of school or something like that. That's, I think that's what that means. You can look it up there. It doesn't really matter what that 3 is. That is being put into, assigned into the spot, seats, row, column of this two-dimensional array. Well, row, column, RC cola. You always, the first set of square brackets is always the row, and the second one is always the column. Whether those variables were named that or not, we go to 0, 0, which means right there. That's where we are putting Karen3. See, that's how that got dumped into there. And now we student index plus plus, and we're done with the if statement, and we're done with the for loop. So we row plus plus here. We check to make sure that row is less than rows. Yes, 1 is less than 3. So we hit this if statement another time, and we work from right to left. But tricky, look, student index is currently 1, which means we go over here and get Liz1, which is in position 1 over here. And it's Liz1, that's the object, or the object reference, but the object that's being put into seats row column. Well, seats row column right now is 1, 0. 1, 0. Is that this one or this one, you might think? Well, it's always the row first. These are the rows. So the first number is row, second number is the 0. That is where Liz1 ends up getting dumped. Yes, this algorithm right now, this solution is correct. It's peeling these students that are lined up in the hallway waiting to get into my September 1st classroom, eagerly awaiting them to take their assigned seats. And I, the teacher, am choosing with this algorithm to assign them to sit all in that first row. See, the teacher's desk is here. I'm kind of looking down at the class. This is that first row of seats that would be physically to my right hand. Some teachers might be the kind of row by row teacher. Some teachers might tell students to sit diagonally, really confusing them. Some teachers tell students to sit wherever the heck they want. Some teachers might fill up the classroom starting in the back row, row by row forward. Maybe even left to right rather than right to left. They could have asked many different variations of this question on the AP exam this year. And they chose to go front back, or rather top down if you want to look at it this way, column by column. Okay, well, let's fast forward because I think you can start to see a pattern if you're following me here. Liz1 got placed, and we row plus plus to 2. At this moment, 2 is less than 3. So we get Paul 4 that plugs in here. And then we row plus plus to 3, and 3 is not less than 3. That's a false. So we are done with this for loop, and we finally hit this curly brace, which matches up with this for loop, which means we come up here for the first time and do a column plus plus. So for the first time, we column plus plus, and this 0 turns into 1. And we check to see if that 1 is still less than 4. Yes, it is. So we now hit the inner for loop another time. And this time, because you're encountering the inner for loop a second complete time, row is initialized as a variable and recreated and set back to 0 because its declaration int is here, and that's just the way it works. You need to learn how to trace double-nested for loops in this course. So row resets to 0. And now we hit this if statement. Is student index, which is currently, oh, I messed up. Student index, just trust me, is now at 3. The 2 is crossed off and it plussed enough times there, I fast forwarded to a 3. So at this moment, 3 is less than 10. In other words, we haven't got through all these students in the hallway yet. And that 3, which is less than 10, causes us to go in this if statement where, this is exciting now, student index, which is currently 3, causes us to do a dot get 0, 1, 2, 3. Lester, and Lester eagerly is waiting to see where he sits, and Lester plugs into seat numbered row column. And the teacher says, hey, Lester, go sit in position 0, 1. And since Lester knows RC Cola, he knows to go to row 0, column 1. He knows to sit his butt right there, which was empty. It was null until he sat there. All of these seats are considered null. Not 0, but null, N-U-L-L, keyword in Java. When you declare an object and you don't instantiate it, it's null. Now we see this algorithm and we know that the second column is going to be populated with the next 3 people in this list. And it's all because of how row plus pluses and column plus pluses. And then every once in a while, the outer loop, when it does when column does plus plus, column resets to 0, allowing for a new column here to populate. Now it turns out there are only 10 kids, but there are 4 times 3, 12 chairs. These 2 never get used up because this if statement is going to end up being false. And it will not execute a couple times in the last full for loop of the inner for loop when column ends up being 3. And there's nothing returned here. This is a constructor. And it just executes. So now the client program can do exciting things with this 2-dimensional array that's populated with student objects. Learn how to trace code in previous year solutions, especially these 2-dimensional array questions. The algorithm is very understandable, and you can even understand this from real life. Imagining yourself as a student with some kooky teacher that wants to fill up his or her classroom chairs column by column rather than row by row or randomly or something. And know that this is just sample data, and you should not, in your final solution, if you were to write this from scratch, you should never have the word Glenn or a number like 6 show up in your code. And certainly not the number of rows and columns even. That's never part of an answer. Almost never. It's maybe 0 is in there, but not numbers like 3 and 4.